Okay, today we start from the behavior of multi-plant firm. Multi-plant firm means firm has two plant. So each plant have different marginal cost curve, for example, right? Suppose our firm has two plants. What should its total output be? And how much of that output should each plant produce? We can find the answer intuitively in two steps. Step number one, whatever the total output, it should be divided between two plants so that marginal cost is the same in each plant. Otherwise, the firm could reduce its cost and increase its profit by reallocating production. So the step one says marginal cost in plant 1 should be equal to marginal cost in plant 2 to produce total output of Q1 and Q2, right? So total production is Q1 plus Q2, right? Anyway, producing some total output, this condition should be satisfied. That is step number one. Step two, we know that total output must be such that marginal revenue equals marginal cost. Okay? Profit maximization condition, marginal revenue is equal to marginal cost. Otherwise, the firm could increase its profit by raising or lowering total output. So second condition is marginal revenue is equal to marginal cost, right? Marginal cost. And first condition is this one. So in sum, this condition is satisfied. That is profit maximization condition for the multi-plant firm. We can also derive this result algebraically. Let Q1 and C1 be the output and cost of production for plant 1. Q2 and C2 be the output and cost of production for plant 2. And total production. So plant 1, Q1, cost function C1. Plant 2, Q2 and C2. Right? And total output Q is equal to output produced in plant 1 and output produced by plant 2, like this. Then profit is equal to, total profit is equal to price multiplied by QT. QT is equal to Q1 plus Q2, right? And minus total cost. Total cost, C1, Q1, right? Total cost for plant 1 and total cost for plant 2, like this. That is profit function. The firm should increase output from each plant until incremental profit, marginal profit from the last unit produced is 0. Start by setting incremental profit from output at plant 1 to 0. Then, algebraic condition is partial derivative of profit with respect to Q1 should be equal to 0. Right? Also, partial derivative of profit with respect to Q2 also should be equal to 0. That is profit maximization condition for multi-plant firm. So now think about this. Anyway, profit function is this one. So this one, partial derivative of this one says Q1 is variable, Q2 is just constant numbers, right? So then P1, Q1, first derivative of P1, Q1 is just price left because Q1 is variable. And PQ2 with respect to Q1, 0, okay, because constant. And minus derivative of this one, C1 over Q1. That is marginal cost, isn't it? Right? That is marginal cost. So, and cost function, this one with first derivative of this one, C2 with respect to Q1 is equal to 0. So this one should be equal to 0. Okay? And second one is, PQ1. I'm sorry. P1, Q1. PQ1, partial derivative with respect to Q1 is not price because market is not perfectly competitive. Okay? So anyway, that is total revenue in Q1, right? Total revenue in Q1. So changing total revenue in plant 1 with respect to Q1. So that is marginal revenue. Okay? So this one condition satisfied. Marginal revenue is like this. Similarly, this one means marginal revenue minus MC2 is equal to 0. Right? That is for two first order condition for multi-plant form. So from here we can derive this condition. Right? That is explained here. So like this, the form should increase. So partial derivative of profit function with respect to Q1 is this one minus this one. And here, this one is the revenue from producing and selling one more unit, marginal revenue, right? And that this is a marginal cost. So marginal revenue minus marginal cost 1 is equal to 0. We can derive this kind of condition. Similarly, from here, we can get marginal revenue minus marginal cost is equal to 0. So putting this relation together, we see that the firm should produce so that marginal revenue equal to MC1. This one is also equal to MC2. That is equation 10.3. So graphical explanation of this, right? In figure 10.6. So that is marginal cost function for plant 1. MC2 is marginal cost of plant 2, right? From when price is the same, MC2, so plant 2 produce more than plant 1. So this means that plant 2 is more efficient, I think, right? Anyway, that is MC1, MC2. So total marginal cost is this one. MC1 plus MC2 at each price level. So we can derive this kind of MCT, right? And this is a demand curve, or average revenue curve, or price curve, as I said before. And the marginal revenue curve is like this. So profit maximization condition say marginal revenue intersect by marginal cost in total when this firm produces QT, right? And this total output QT divided by production by plant 1 plus production by plant 2. That is Q1 and Q2, right? So Q1 plus Q2 is equal to QT. That is a graphical illustration. Okay? Then we go next slide. Figure 10.7, the demand for toothbrushes. Part A shows the market demand for toothbrushes. Market demand for toothbrushes. Part B shows the demand for toothbrushes as seen by Form A. So Form A is marginal cost, demand curve, marginal revenue. Right? At the market price of $1.50 here, elasticity of market demand is minus 1.5. Right? Price elasticity of demand. So large letter D means market elasticity, right? That is minus 1.5. Okay? Form A, however, sees a much more elastic demand curve DA in panel B. DA is this one, right? More elastic than this. So Form A's demand elasticity is price elasticity of demand by individual form is equal to minus 6, right? So Form's price elasticity of demand is larger than market elasticity. Still, Form A has some monopoly power. Its profit maximizing price is $1.50, which exceeds marginal cost. So, and here, so second point is that anyway, in panel B, marginal cost intersects marginal revenue at this quantity, and price is $1.50. Okay? And from here, we know that price is greater than average cost. Okay? That is price curve. So average cost should be like this. Right? So average cost, marginal cost, average cost should be lower than like this. So price greater than average cost. In other words, think about this. This is positive, price greater than marginal cost. Right? Price greater than marginal cost. Okay? That is markup, price markup. Right? So measuring monopoly power. Okay, slide number 21, example 10.2. Elasticities of demand for soft drinks. Soft drinks provide a good example of the difference between market elasticity of demand and firm's elasticity of demand. As we already studied, firm's elasticity of demand greater than market elasticity of demand. In addition, soft drinks are important because their consumption has been linked to children obesity. There could be the health benefit from taxing them. A recent review of several statistical studies found that the market elasticity of demand for soft drink is between market elasticity of demand and soft drink is 0.81. That is minus 0.8 to minus 1.0, right? That means that if all soft drink producers, all firms, increase the price of their brands by 1%, then quantity of soft drink demand decreases by 0.8 to 1.1%. Okay? That is meaning of market prices. Price elasticity of demand at the market. The demand for any individual soft drink, however, will be much more elastic because consumers can readily substitute one drink for another. Right? Although elasticity will differ across different brands, studies have shown that the elasticity of demand for, say, Coke is around -5. Coke's individual firms' price elasticity demand quite larger in absolute number than market demand. Why? Coke increases the price. Then consumers demand, for example, Pepsi rather than Coke. So substitution happens. So firms' elasticity larger than market demand. Students, so this says that what is the meaning of individual price elasticity of demand? If Coke increases price by 1%, but the price of all other firms remained unchanged, then quantity of Coke demanded would fall by about 5%. That is meaning of this. That is minus 5%. Right? Minus 5%. So this means that all firms increase their price. Then what happened? The quantity demanded decreased by like this. This said, one firm increases its price by 1%, and other firms do not increase its price. No change. Then demand for a brand who raises its price decreases greatly. Okay? That is example 10.2. And next section, monopoly power. Monopoly power. Production price and monopoly power. In figure 10.7, although firm A is not a pure monopolist, it does have monopoly power. It can profitably charge a price greater than marginal cost. Price greater than marginal cost. Of course, its monopoly power is less than it would be if it had driven away the competition and monopolized the market, but it might still be substantial. This raises two questions. Number one, how can you measure monopoly power in order to compare one firm with another. So far, we have seen taking about monopoly power only in quantitative terms. The answer for number one question is this one, right? So we already studied this kind of thing, right? So price, charge higher price than marginal cost. That is positive. That means individual firm has monopoly power. Number two, second question. What are the sources of monopoly power? And why do some firms have monopoly power than others? We address both this question below, although a more complete answer to the second question will be provided in chapter 12. Okay? So, next slide. So, measuring monopoly power, answer for first question. Remember that the important distinction between a perfectly competitive firm and a firm with monopoly power. For the competitive firm, price equals marginal cost, right? When the market is perfectly competitive, price equal to marginal cost, right? That is profit maximization and when the market is perfectly competitive. For the firm with monopoly power, price exceeds marginal cost. Price higher than marginal cost, or P minus MT higher than 0. Right? The ability to charge a higher price than marginal cost. That is a measurement of a monopoly power. Right? The most important indicator for this monopoly power is, we said, Lerner index. Lerner index of monopoly power. Then what is Lerner index? Lerner index is this one. Right? Lerner index, indicator of monopoly power is price minus marginal cost over price. We said that is Lerner index, right? So we know this one positive, then this one positive, right? So firm has large of monopoly power. This value is very high numbers, okay? That is positive, and anyway has monopoly power. Also magnitudes matter, okay? And we already studied that this equation. That is equation 10.2, 10.1, I forgot, 10.1, 10.2, right? So that is this. And we know this Lerner index is this one, right? So we know that Lerner index is equal to minus 1 over reverse value of price elasticity of demand. That is equation 10.4. Okay? So actually we already studied this. Now we go next slide. The rule of thumb for pricing. Price is equal to this one or this one. Right? That is equation 10.1, 10.2. I don't know. Anyway, price is like this. Figure 10.8, look at these two figures. So, one is this one, and one is this one. First, look at panel A. Marginal revenue is equal to marginal cost. So, profit maximizing quantity should be Q star. When Q equal Q star, price is P star, right? And the marginal cost is here. Marginal cost is equal to marginal revenue, this one. So P star minus marginal cost measured by the gap between these two. Okay? Not so large. But look at this. Marginal cost, some same marginal cost curve, right? The shape is very similar. This is a price curve or average revenue curve or demand curve. And marginal revenue curve is like this. Then marginal cost intersects marginal revenue at this Q star, right? That is profit maximizing quantity. At this Q star, price is here. Then price minus marginal cost is this one in this graph, panel B of this graph. We know that price marginal cost markup greater in panel B than panel A. Okay? Then why this one is so large? Why this firm has more monopoly power than firm in panel A graph? Why? Because different shape of demand curve, isn't it? Okay? Or, simply talking, this one, price elasticity of demand. Different value of price elasticity of demand. That is figure 10.8. Let's look at. The marker P minus MC over P, or Lerner index, is equal minus the inverse of the elasticity of demand. The inverse of elasticity of demand. If the firm's demand is elastic, firm's demand curve is elastic, firm's in panel A, firm's price demand curve is like this, so elastic, right? Firm's demand is elastic, as in A, the markup is small. Markup is this one, right? Markup is small. And the firm has little monopoly power. The opposite is true if demand is relatively inelastic. Demand curve is shaped like this, inelastic demand curve. Then markup, large markup, right? That kind of thing happen. So no problem to understand this. Okay, then we go next slide. Number 25. Slide number 25. Example 10.3. Markup pricing supermarkets to designer jeans. Although the elasticity of market demand for food is very small, right? Market elasticity of demand is very small. This one is very small, right? Okay, for example, about -1 in example 10.3. No single supermarket can raise its price very much without losing customers to other stores. In other words, price elasticity of demand is different. The elasticity of demand for any one supermarket is often as large as -10. That is -10, quite large, right? We find that, so, okay, now think about this equation, right? This one is -10. This one inserted here, okay? Then, okay. This one is -10. So then price is equal to marginal cost over 1 plus 1. That is -10. So -10. Okay? So we can read, right? Minus sign, moving, transfer to here. Then just this one left. Okay? So 1 minus 1 over 10 is 0.1, isn't it? Right? Then 1 minus 0.1 is 0.9. This one is 1 MC. Okay? 1 divided by 0.9 means approximately that is equal to 1.11. Rewriting this one is 1 plus 0.11. 0.11 means 11%. Right? 0.11 in numbers is equal to 11%. That means price markup is 11%. Right? 1 MC plus 11% MC. So 11 MC. The manager of a typical supermarket should set price above 11% above the marginal cost. Okay? So individual supermarket charge markup over marginal cost is 11% when this one is -10. Okay? Small convenience stores typically charge a higher price because its customers are generally less price sensitive. Because the elasticity of demand for a convenience store is about -5. For example, this one is -5 in convenience store case. Then also we can calculate this one, right? When price less demand is -5, then price is equal to marginal cost 1 plus 1. Price elastic demand is -5, right? Minus sign. Then we can rewrite like this: 1 minus 0.2. Then this one is 0.8, right? 0.8, 1 divided, and like this. 1 over 0.8 it means 1.25 marginal cost. That means 1 plus 0.25 or 25%, right? Like this. So price markup over marginal cost for a convenience store is 25%, right? Also, final example is designer jeans. Demand elasticity in the range of -2 to -3 are typical. This means that, for example, -2, right? That is -2. Then what happens? Price -2, then 1 plus 1 over -2. That means 1 minus half. That means half. That means 2 MC, right? 2 MC means 1 plus 1 MC. 1 in numbers is equivalent to 100% MC. So designer jeans markup over marginal cost is 100%. Okay? That is here. So if this is -3, okay. Then we go next example, 10.4. The price, before that, I'd like to explain one more. If this one is -3, so calculation is same. Then marginal cost 1 minus a third. A third means 2/3, right? That means 1.5 MC. 1.5 MC means 1 plus 50% MC. So price markup over marginal cost is 50%, right? So you have to practice fully for this kind of calculation. Okay, then let's go example 10.4. Example 10.4, the pricing of video. When the market for video was young, producers had no good estimates of elastic demand. As the market matures, however, sales data and market research studies put pricing decisions on firmer ground. By the 1990s, most producers had lowered price across the board. Right? So look at this retail price of video in 1985 and 2001. This one, VHS is like this, right? And DVD price is like this. Retail price of DVD is like this. So graphical illustration of pricing of video represented in figure 10.9. Video sales between 1990 and 2004. Lots of things changed compared to earlier one. Lower price induced consumers to purchase many more videos. By 2001, sales of DVDs overtook sales of VHS video cassette. Originally, VHS video cassette is popular and number one type, right? But year 2001, this one changed. Look at this, right? This one. Black one is a DVD player. So this one increased greatly, right? And VHS's decrease. VHS's share decrease, sales decrease. But this DVD sales increase and overtake, right? And the third type is this one. High definition DVDs were also introduced in 2006. So you can see a very small one, but you can see this one, right? conventional and were expected to eventually displace sales of conventional DVDs by year 2008. However, sales of old DVDs, conventional and high definition, began falling rapidly as they were replaced by streaming video. Okay, I'd like to stop here and next, section 3.